I think there are still a few people late back from the coffee break, but if you snooze, you lose. So we're going to get going today because we've got a lot of very exciting speakers and a lot of very interesting things to talk about today. And so without further ado, I'm going to welcome Stuart Campbell. Stuart, as I think most of you will know, works for TLC. Do I say TLC or do I say the Lottery Corporation?
We are meant to say the Lottery Corporation.
We are meant
these
to say
days, yeah. You know, not a lot of shortened names these days.
Very good. So the Lottery Corporation, not to be confused with TLC. Stuart's doing some really amazing, innovative work with the Lottery Corporation, and I'm going to get out of the way and let him tell you all about it. Stuart, thank you.
Thank you. Yeah, so Stuart, I'm the head of analytics and AI at the Lottery Corporation, or TLC. I mean, you are allowed to say it. I'm just not allowed to say it. So we'll skip through. That's a duplicate slide there. So the Lottery Corporation. So just to give a bit of a brief overview of what we are. We're a nationwide lottery provider. We also provide Keno services across the country as well. We have one of the largest retail networks in the country. And we have some of the most well-known brands, again, in the country. So these are some of our jurisdictional brands and then our game brands you can see down there. Each different jurisdiction has their own brand identity, which enables us to have that closer personalised relationship with the business. Outside of this, what we don't see here is we also have a charitable games partnership that we have with a charity provider. And we run their charity lottery systems, which is another contribution back to society that we have there. What we're here to talk about, though, is we're talking about what we've done with AI. Now, when it comes to the Lottery Corporation, you've probably heard all the statements. In fact, we just heard it in the keynotes before. 86% of models, or you know, even to the degree, I think it was 64% in the presentation, don't make it to production. We're a little bit different than that. For us, we're actually 94%. I just felt like 94% was maybe overkill, so I've cut it back to 90% of our models have made it into production. And we've done that with the very limited resources. So we have only ever had 2 data scientists at any one time, but we've been able to push out 30 plus models. In fact, that's significantly more than that if we include some of the programmatic pieces of work that we have, where we've got about 30 models in one of those programmatic pieces of work, which we'll actually go into a little bit more into detail later on. Because we've been able to do this, we've been able to get up to a 90% productionization. We've done it with such a few people. We've actually expanded our remit quite substantially within the business. So we started in customer and marketing, building out personalization models, churn models, all those standard customer and marketing level activities. We are now building into business operations. So what we are now doing is building into business operation activities where we are supporting cost reductions, efficiency gains, risk mitigation, investigation work, the whole shebang. And unfortunately, good work builds more work, so that is an ever-expanding piece. And we are still doing that with just 2 data scientists and a small engineering team. How do we get stuff to 90%? It's a little bit different to my slide, but that's okay. How do we get it to 90%? It's, for the most part, it's a platform. Platform first is the way that I refer to it, is most of what you're seeing up there is what we've done with Teradata. So Teradata has, for the most part, developed alongside us our whole process. So we follow the CRISP-DM data mining activity, which was co-developed by Teradata. It was given to us by Teradata, and we've just taken it on and taken ownership over that within our process. A platform that enables us to scale very quickly, being able to store models within the BIM system, be able to run them, deploy them, score them, all within database. It makes it a very efficient and cheap way of processing our models at scale. And model ops. We have only got 2 data scientists. We've got a small engineering team. Model ops is key to making sure that we can scale all the volume of models that we have and account for stuff like model drift, measure the success of our models, report on that to the business. So one of the big key changes that we've made in the last about 18 months is we're now reporting up to ELT all of the success metrics of our models. So not just are they accurate, but how much are they shifting the needle on the business. So each individual model now has what we are referring to as a MUSE, or Model Universal Success Engine, assignment. So we then report that up to the ELT, and we do that because of our model ops. So it's like an extension to model ops into model success. Now, what's at the front end of that is what's referred to as deliver agile, but the way that I like to refer to it is it's business-led initiative. So what that means is the business is the one that is driving the activity. So as much as what underpins the whole process is Teradata, it's BIM, it's the CRISP-DM system. What makes us successful and being able to get us to production is the fact that the business is the one that has brought into the program. They're the ones who own it, we're just the ones who run it. So ownership is with the business, and because ownership is with the business, they have that investment to make sure that they are driving success. Where we started was with personalization though. The reason we have personalization is because that's what customers want. Now, customers are clearly wanting a higher and more degreed personal communication through our comms channels. But there is a level where it gets too much. So what we're seeing here is particularly at that last point, which is that 93% want to not be targeted. So yeah, 93% don't want to be overly targeted. So there's this fine balance that we have to play with between personalization and unwanted contact. And that's where our AI models stem in. So we can give the right message at the right time, through the right channel, enables us to be able to deliver on that promise and on that expectation of the business. These are some of the models that we've been able to produce. Now, when it comes to personalization, we're talking about next best offer. Now, next best offer is just a broad-based term for a number of series of models where it's like a customer recommendation engine. So we are using propensity and our propensity to spend, multiplying that all together and coming up with what's the right product on the right day for the right customer. So when they either land on the channel or if we want to do direct communications with the customer, we know what's the right product and what's then the hierarchy of products after that that we should be offering. So what's their number one purchase, number two, number three, etc. We also have built churn models. So actually using the engine that powers NBO, because it's working on propensity, it then also has the ability to build churn as well, because it's looking at the customer's likelihood to purchase, and you can do that on a likelihood of purchase at any one individual product or on any at all, so on that customer to business level. So we've then been able to extend that program out, build a churn model. An engagement model as well. So engagement model is about that right message at the right channel at the right time. So it's about predicting when to send the message, how to send the message, and which message to send. So add all those together, and we are sending the right message, we're communicating with the customer at the right time, and we are driving not just retention, we're driving sales, and we're driving what we like to call is brand spread. So we don't want everyone just to buy one part of our business, we want them to have the spread of our business, and that's where you can then talk about more data science level activities like model injection. So that's where you inject in randomization within a model so that you are not rebiasing within a model. So if you want to go into more detail, you can talk about it, we can talk about that later, but that's just one of the aspects where we can start to drive more engagement. One of the key parts within a lottery or gambling organization is making sure that our customers are playing responsibly. So we have a responsibility as a responsible gambling operator to play responsibly, to provide services responsibly, but we also have a program of work to make sure that our customers play responsibly. So what we do is we have an early intervention model system. It's a series, again, it's another series of models that we have available that try to predict when customer gets into harm, and we try to stop that as soon as it possibly can. And we'll go into that a little bit more detail in a second. Once we've talked about next best offer, the next logical step is also cross-sell models. So this is using just standard market basket analysis work on top of what we've done with the NBO. So this is what to offer when they've added to cart, what should be their next add to cart option. And then what I was talking about before was we're expanding our remit. So we are also optimizing the business. So we've got retail anomaly detection models. This is a series of about 30 to 50 models at this point. It is a ever-growing and ever-expanding area of our business. We opened the Pandora's box, unfortunately, with risk and investigations, and they've not stopped coming back to us for more models. So this is a large series of models where we are trying to find within the retail network specifically where there could be what we refer to as policy breaches. I'm not going to call it fraud because that's for the investigation team to decide whether it's fraud. But we're looking for anomalies within the series, anything that's unusual, anything that's a policy breach, and we'll go into a little bit more detail on that one as well. We've got selling a dream a day. That's a very simplified model where if you think about NBO, we're trying to predict every single customer's purchase on every single day. This is more looking at on a retailer and jurisdictional level, what's the sales are going to be like. So we can then control the marketing material that are in store. Cost optimization model. So we have a lot of collateral that goes out, so probably a lot less than most companies, but we still have a lot of collateral that goes out to the retail network. And we ran through after a hackathon, we did a quick hackathon, and we built a cost optimization model that's now saving the team close to $250,000 every year. We have a terminal log restructure model. So this is also another one of these models as part of the retail anomaly detection model that got extended out. And this one is terminal logs come in various different unstructured formats. Our investigation team wants to review through them. So we've gone and created a model that will restructure all of that data and then put an analysis over the top of it. So it's quite a complex series of ingestion of data and then be able to push that out into a structured format so that we can actually run analysis over the top of it. And then lastly, we've got the code converter. So we've gone through a program of work to try to move all of our SAS code to Teradata. Now, there's no simple way to do that, but what we have done is we've used Open LLM to load in the SAS documentation, load in the Teradata documentation, and then we can natural language query our code base and say, ask it to convert our code across. That has been quite successful, and what we've been able to do with that is meant that we are not running actually a project to migrate off of SAS at this stage. We are doing that all within in-house and just as BAU. So that's again saving us about $250,000 just in project costs alone by leveraging LLMs. So some of the benefits that we've experienced. So Next Best Offer has had the largest amount of advantages. Not surprising, we're targeting customers at the right time with the right message, with the products that they're actually after. And this is just the beginning. Right now, we're not even utilizing stuff, what's within this model, which is Next Best Ticket, which is actually not just the products that we want to offer, it's the type of product within the product that we want to offer them. So this is going to get even better again. So we've experienced significant growth within both the direct marketing systems, so CRM, and paid media has had a vastly increased return on ad spend. We've also, outside of that, we've also driven a significant increase in incremental revenue. We're talking numbers of millions of dollars. I can't say exactly how many, but it is tens of millions of dollars in additional incremental revenue as well. Our early intervention program, so what we've also done as part of our early intervention program is we've had to go on and create our own model to measure success. So there is no universal application as to what is a successful movement within early intervention. We had to go create that ourselves as well. From that investigation work, what we've found is we've been able to shift the needle on customer behaviour in the lottery space by 12 times. So, and in Keno, it's a bit less at 4 times. Now, it's the nature of the products. Keno is a higher frequency product. It's a higher addictive product, so being able to shift the needle in Keno is a lot harder than it is in lotteries. And then in our retail anomaly detection, we have saved countless hours. This 13-hour saving, that was when I first started building this pack, which was a couple of months ago. That's now up to over 20 hours per consultant per month. So significant growth there. And what that has done is it's also enabled them to grow the amount of investigation work they're doing. So we're providing them an additional volume of investigation work. And because of the hours saved that we've been able to provide them with the analysis pieces, they can now investigate at a 40% growth. And it's proactive as well, which we'll go into in a second as well. So let's go into a couple of our models that we've got. So this is our next best offer model. This is as simplified as I could possibly make it. So our next best offer model is, again, it's a series of models that what we're trying to do is work out what the propensity of someone to purchase any particular product, what their spend likelihood is going to be in that particular product. We do this on a daily or weekly basis. So we're about to move to a daily model. We've already built it. It's ready to go. Right now, we've got a weekly model. If you think about a lottery product, most lottery products are weekly based. So it's every Thursday, you've got one different product. Not every Wednesday, you've got a different product. So on a weekly basis, it makes sense. But we're actually going to move that even further again and move to a daily model. We then also look at what the churn rate is going to be as well. Now, if you actually multiply all this together, you effectively get what's referred to as an expected value. So if you have an expected value for every single product, for every single customer, you can then rank those expected value marks. And then that is effectively your choice rank system. What we can then utilize this for as well is stuff like our early warning system for churn. So we can try to stop customers from leaving because we know which product they're going to leave from, which product they're going to most likely purchase into, and be able to shift the way that we market to customers. The other, actually, what I haven't mentioned is also, as part of that, is we can also do not just retention, it's reactivation as well. Because we also know which products to reactivate a customer through as well. Forward to this, we've got some more experimentation that we've been doing with NBO. So our digital team is probably one of the biggest users. So outside of our CRM team, who we actually developed it for originally, our digital team, which works on personalization within the apps and the app and web, have been experimenting with the NBO utilization and how to actually use it correctly within the system. That we've had massive growth in both add to cart and average transactional value. And click-through rate as well, which I haven't shown before in the CRM system. So it's had great success. And we've done a ton of A/B testing to make sure that it is exactly the way we want it to look. But we're ever evolving. So this model is into its 4th version. So we're into NBO version 4. We're about to build out NBO version 5 as we go through a CDP transformation as well. Our early intervention model. So this is the key to protecting our business. So if we consider our business is a social licensing business, so we have a monopoly license to operate the lotteries in Australia. The only reason we have that in every jurisdiction, except for WA, don't get me started, is because we protect our customers. This series of models is about protecting our customers. So it not just reduces the harm to our customers, it reduces the harm to our business entirely with our social licensing cost. By allowing customers and making sure that they play safely, it provides us a base load of our models and provides us a base system that makes sure that the customers will continue to play with us. Now, I've tried to make this as simple as possible as to how we've done this. Again, if you want more detail, I'm happy to go into it. This is the sort of thing that I want every sort of business to have some version of this, where it's a protection of your customer base. So what we have done, and we've worked with a behavioural scientist by the name of Juliet Tobias Webb to build out a series of markers of harm. So these are just feature points within the customer player behaviour that are considered potential markers of harm. We then measure the harm. Now we do that using stuff like the ClearScape analytics systems, where we are trying to use those advanced statistical engine to do coefficient of variance, slope calculations, all that sort of like cool statistical stuff. And we do that on every series of those markers of harm. We then, once we've measured the harm, we can then rank the harm or score the harm as the case may be. And just to make sure that if we have not hit everyone, so what these models are really trying to do is look for changes of behaviour. So if you think about like a slope or a coefficient of variance or standard deviation away from the mean, any of those sort of calculations, what we're trying to look for is changing in behaviour and people changing in a negative way. The risk of that is that customers will continue to play in a poor behaviour. So if they're consistently poor, so let's say they're consistently spending $1,000 a week or plus on lottery, but that behaviour is consistent, there is no change in behaviour, and thus what we have then built out is safety nets. So we are going through a series of building out for every single marker of harm a safety net level that we go, if you still breach this level within this period of time, then you'll be picked up as well within the model. So this is making sure that we are capturing everyone that could potentially be at harm. Then once we've scored them, once we've risked them, we then can intervene. And our intervention needs to be matched to what they're doing in their behaviour that is suggesting that they may have some harmful behaviours. I don't want to say that they actually are at risk, but what we try to do is intervene before that point anyway. So we are trying to then match our campaigns, our activities, our calls to those markers of harm that they are breaching on. And then we can measure the success of that based on the changes that they experience. Our retail anomaly detection models, again, as I think I've mentioned before, it's a series of models. It's a series of, it's about 35 models at the moment that is ever expanding. I think we're probably looking by the end of the year to get up to maybe 40 models. These are a mixed series of models. So some of them are machine learning models, all activated through BYOM, or they're analytic models. So utilizing part of the ClearScape analytics tools. They're analytic-based models that are run, everything's just run directly within Teradata. It means that we can do this at cost. So this part of the business doesn't have any significant amounts of funding. So a lot of the activities that we need to be doing is we need to be doing them at zero cost effectively, like zero cost. And the only way we can do that is with Teradata. So these models are a series of models. So they're either doing behavioral anomaly detections within the business, or they're doing actual rule-based or business-based rule breach detections. We've then built out a whole bunch of series of reports off the back of all these models for the investigation team to use. So this is, the whole program of work is referred to as our Retail Investigation Forecasting and Engagement, or RIFE, series of models. An example of some of the models that we are building within there is, let's say someone buys a ticket at a venue and they cash it in a venue that's 200 k's away, and they do that within the hour. You can't do that. Because of that, that's a potentially fraud-based activity. It means that the investigation team needs to look into it. That stuff happens because effectively, if someone is trying to send funds to someone else, the way to easily do that is by purchasing in one location, cashing it out in a different location. So we have rules that they can play with, and we give them parameters that they can play with to say, is it 60 k's an hour? How fast should someone have to travel to actually purchase that ticket. We also are trying to pick up staff doing incorrect behaviour. So if we get a series of tickets being checked, so as in they're putting it through the system to check to see if it's a winner, and we get like a bunch of those all in one go, then that's generally considered potentially worthy of investigation because someone is clearly just pulling it out of the bin and trying to run it through the system. There's these sort of things. We're also looking at people that purchase a ticket late at night and then try to cash it first thing in the morning. So that's potentially a series of staff behaviours that we are trying to stamp out. So that's just a couple of examples of some of the rules that we are trying to breach on. And then when it comes to anomalies, we're trying to look for spikes. So we're trying to look for where activity just is unusual or and doesn't follow a pattern. Looking ahead. Now, I haven't really talked about Gen AI because we're actually really just starting on that journey. So really excited to see what's been talked about so far about what's coming in the Gen AI space within Teradata because that's really where we want to be heading. So our intention is to start building out some RAG models. So we've already got a couple of POCs on the go. We're not doing it technically through Teradata at this stage because we're trying to look for quick roll-ups of POCs so we can prove it to the business so that we can get some investment. From here, so not just our AI generation content AI content generation. So what we're trying to do here is, what we've talked about is selling a dream a day. Why people play the lottery is because they're dreaming for something big. We have the opportunity with content generation to actually give everyone personalized content and personalized marketing content directly to the dream that they have. So if you want a boat, that's why you're playing the lottery, is you want a boat, well, our marketing will be boat-based. So if we can get that hyper-personalized content generation on top of the right product at the right time, we are literally giving the customer exactly what they want with the dream that they want. So we're going through a program of work with Adobe to work through what that potential content generation system would look like. Domain knowledge agents. So we're going through what's called an upside-down triangle of domain knowledge bots, which is effectively like RAG models, where we are going through from generalized divisional layer models down to hyper-specialized agents for, if it's a coder, if it's a developer, if it's someone working in strategy, they're agents directly specific for their particular role. And if you think about it like that, an upside-down triangle, it's very generalized down to hyper-specialized. We're also wanting to utilize some of the new stuff that Teradata is coming out with, the IVSM side of things. So I think which has been mentioned in some of the sessions, which is utilizing large language models built within Teradata. So simplified large language models to then do predictions on our jackpots. So one of the best ways for us to make a little bit extra money is if we can manage our jackpot rolls. So we don't really get any control over that. It's randomized. If we had control, wouldn't be a random game. What we can do though is assist our business by predicting the frequency of those draws based on the purchase rate of customers, because it just changes the odds throughout it. It's a lot of statistics, and it's a lot really hard for most engines to handle that volume of work, which is why we haven't done in the past. With transformers, there is the opportunity now that it can make those processes at a frequency that will enable business decisions. So we want to try that out. We've already done that collateral optimization work, and that has now spawned stock order optimization work. We don't have a lot of stock order optimization. What we're trying to also do is do cross-retailer distribution. So we have a lot of scratchy tickets. So scratch-off tickets, I don't know what everyone else refers to them as, but we sell, that's part of our brand offering. There is, what we have already seen in the data is that some retailers will sell some products really well, and other retailers will sell other products. We want to look to enable a system where we can integrate those retailers together and to do cross-selling within their systems so that they can have an optimized stock levels in each store. We don't own the network, so everyone's a franchisee, so what we're trying to do is more be a facilitator there of stock movements between stores. Again, the only way we can do that is with data science. we've previously had a geo outlet notification system, so geofencing different locations so that we can do notifications, in-store activities, in-store commission-based work as well. So one of the things that a lot of retailers are screaming out for is more commission, no shocks there. And one of the things we can do to support that is with geofencing. And that's where we're hopefully heading. So a lot of work, particularly in the domain knowledge side, is where we're wanting to get big advantages in the business and drive additional revenue and hopefully reduce costs as well. And that's us. Thank you.
Thank you very much, Stuart. Don't run away, because we've got a couple of minutes, I think, before lunch.
I hope I wasted my time there.
Well, I anticipate we might have some questions. While you're thinking about those, I'll just kind of pick up on a couple of things. I love when you talked about going from model ops to model success. I thought that was really inspirational, and I guess it does come back to something we talk about a lot at Teradata, about the importance of operationalizing AI and machine learning at scale. And I love the fact that it's also an ELT discussion at TLC. Did you see what I did there? Sorry, at the Lottery Corporation. I mean, I think that speaks to the importance of AI and machine learning, the AI and machine learning agenda in a lot of businesses right now. But I think it also speaks to how successful you've been in demonstrating the value of what you're doing and selling it internally as a way of keeping the whole machine spinning and working, if I can put it like that. I also love the discussion about harm reduction. I think you're going to hear a lot from Teradata, and you have heard a lot from Teradata about trusted AI. I think trusted AI is ultimately responsible AI, and using AI and machine learning for harm reduction in that way, I think is incredibly important, to your point, and the right thing to do, but also good business, to your point, because if people are getting themselves into that kind of trouble, then you're not building a long-term relationship with those customers as well. So, and 40 models for anomaly detection alone, anomaly detection at zero marginal cost. The only way we can do that is with Teradata. I may quote you on that over and over and over and over, I suspect. Well, all right, so are there any questions out there in the floor? You've got Stuart all to yourself. Yes, there's a microphone coming to you right now, sir.
Yes, thank you. I would like to know, what is the technology for the recommendation engine in the CRM use case? A software or a...
So the recommendation engine, it's purely built on Teradata. So a lot of the models we develop in AWS SageMaker and then deploy through BOAM onto Teradata. Now, and then what we refer to as our customer recommendation engine is just a series of machine learning models that then deploy into what we call a customer 360 view, which then gets deployed then into every channel.
Okay, thank you.
Another question at the back, and while the microphone's going there, I'll just mention that I think many of you in this room will be familiar with our Bring Your Own Model technology. For those that aren't, obviously ClearScape is a set of end-to-end AI and machine learning capabilities. We have lots of customers that run the entire AI and machine learning lifecycle with Teradata. For those that don't and want to use other tools for model training, if you can serialize those models in PMML, Mojo, or Onyx, then in general we can score them in Teradata, and normally better, faster, cheaper than alternative approaches. Of course, I would say that, wouldn't I? Sorry, you had a question.
Well, I would say it too, so it's fine.
Thank you.
Hi, so Kaylee Dwyer, and it's a two-part question. So you mentioned that you only have 2 data scientists at any one time. So firstly, can you share the average of what that speed to production is like? And then the second part of the question is, with only 2 data scientists, how do you balance the prioritization of satisfying your customers' needs with retaining value and obviously monetary value in that journey?
Yeah, so I'll start with what was the first one again, sorry?
Time to market.
Honestly, our time to market is really fast. So effectively, I think we've talked about, in the keynote today was about removing the roadblocks. We don't have roadblocks because we don't have the volume of staff to create roadblocks. So we are very fast led. So when we get a business objective, we use that crisp DM approach. So that whole process that I touched on is effectively what drives our speed. So we do a lot of quick POC work to make sure it's going to be successful, or whether it needs to be a data science model. So that's part of the crisp DM approach, does it need to be data science-led approach, or does it need to be an analytic-led approach? And whether it needs to be then handed off to our analysts. We've got plenty of analysts. What I don't have is data scientists, unfortunately. So Is that prioritization there? As far as prioritization of the actual work itself, we go through agile sprint work. We work with the business, so we have meetings with all of the, not the ELT, but the leadership teams of the different departments, and we walk through them every single month on what the prioritization within the data science streams are going to be. So we always have a 12-month roadmap with a sectioned off times for random stuff that comes in.
Daniel, looks like you've got the microphone.
Thank you. Thank you and congratulations on the presentation. Great to see there are no scrubs at TLC. You certainly seen quite a few things with just 2 data scientists. My question is, in terms of the orchestration of the anomaly detection models, could you elaborate a bit on that? How do those play out in tandem on a day-to-day basis?
Yeah, so they're daily run. So they are orchestrated all through stored procedure scripts that run and query and call on the models to run. So they run all in parallel. They then get produced into a series of reports for the investigation team to review. We also then, as part of that, also have analytic reports that they can then interrogate to review to see if it's worthy of investigation. So you have one that picks up, is it worthy of investigation, and another one that then they can drill down even further again and then work out, is it really worth their effort to go in further. It's so much so that they went from 2 investigators to now 5 investigators. So, they've expanded their team to cope with the increased workload that we are doing. The big advantage is it's now proactive. So previously, all investigation work was reactive. It was an issue has occurred, let's now investigate. This could be an issue, or it's a building issue. It's worthy investigation.
So it's like a waterfall approach.
Sorry, did you have
So like a waterfall approach?
Yeah. Pretty much, yeah.
Okay. No scrubs and waterfalls. You got the right TLC.
And there we go. I like what you did there, Daniel.
I did. Yeah. I'm going to use it.
I never would have thought of lottery games and fixed odd games being a way of kind of nefarious money transfer or money laundering. But that example that you provided was really interesting, right? I mean, not only can you not buy and cash a ticket 200 kilometers away within 1 hour. It's not physically possible, but obviously there's malign intent in that transaction, right?
Yeah, and it's also cancellations as well. So one of the other things is you can cancel a ticket. So if the draw hasn't occurred yet, you can cancel the ticket and you can cash it out. Now, if I take a screen capture of that ticket, send it to my mate in a town somewhere else, he can cancel that ticket using the same code base. So all risks, and it all means you can transfer money. And it's not something that we had even really thought about until we started to pick it up, and now it is a part of our models.
Yeah, and a really good reminder, folks, that Teradata, amongst its many qualities, is also a fabulous geospatial engine. So if you've got problems that have a time and space component, don't overlook those geospatial components. For those of you that are Teradata customers, you've already paid for them, yeah, and they work really, really well.
And we actually use the geospatial stuff also for our public relations team. So our public relations team, who talk to all of the politicians across the country.
All of them except the ones in Western Australia.
Except for Western Australia, we don't talk to them. But what we do is we can then allocate every single customer, every single transaction down to their location, and we can have that hyper-personalized conversation with politicians. We use the geospatial polygons to do that.
Fascinating stuff. There's another question, I think.
Yes. Sorry if you already mentioned that, but I didn't heard if you use Teradata Data Lab in your agile process for POC experimentation.
Right now we don't. So we pretty much do our dev work in the AWS SageMaker. So what we've done is we've gone and created our cleansed data lab. I'll call it a data lab, but it's not Teradata's data lab. It's just a database that has been cleansed of all transactional level information, customer level information, other information points. And that is what we call our model database. From that model database, we will do quick POCs on that model database. If the data doesn't exist in there, that's when we go outside of Teradata. We'll do the testing within Python on AWS SageMaker, pull the data in that we need to, see if it works, see if it's worthy. Then if it is worthy, then we pull it into that model database. and then from that model database, we then productionize.
And I know from the conversations that we were having yesterday, Stuart, that I think one of the things that you're thinking about in terms of further productivity improvements and enhancements is kind of extending that. We would, in Teradata speak, call it a feature store. I don't think you use exactly the same word, but thinking about how you can reuse some of the features that you've already created to support the existing models.
Yeah, 100%, because we've done, we do really well with the model store side of things. We do poorly at feature store. So what we do at the moment is, every new model has this features and it just goes into that feature store, and that feature store just becomes bigger and bigger and bigger. It's getting to the point of it's too big. So we need to start optimizing back and rationalizing what we've got in that feature store, as well as then doing what I've been talking about is doing layered versions, so hierarchical features. So you've got a primary feature, then you can have sub-features as well, which has the potential to really rationalize down the levels of detail that we have in a feature store.
Cool, thank you very much. Any more questions? Going once, going twice. Then I can officially declare that it's lunchtime. Enjoy your lunch. Yep.
Thank you.
Give it up for Stuart one more time, thank you. Enjoy lunch. We'll see you back here because this is the track that matters after lunch. Thank you very much.